Is 7.4, the second part. It's going to be the same as that first video, but it's going to have inequality signs instead. Okay? So I want you to go ahead and write down this key concept right here. And kind of think to yourself, what does that mean? Okay, so X is A and Y is E. Keep that in mind. And 7th period, I'm doing this live with 4th period.
Oh, it's rolling right now?
Yes. So what this means is, same thing with an equal sign, but now we have an inequality sign. So you can set up with a greater than sign. Notice that for the less than sign, why do we have to add this piece right here? Why do we have to do that?
Because X has to be greater than 0.
Right, because this, remember this piece right here, the X has to be positive.
Oh, yeah.
Okay, always has to be positive because that's like our A. All right.
Alright.
So we're going to set this up using A again. But now we have a greater than sign and a less than sign. So this one right here will have, it'll be X is greater than 3 to the 4th power. So X is greater than 81. So do we need to set up the other portion of it? Do we need to make X greater than 0 at all?
No.
No, we don't.
No.
Because it's already greater than 0, it's greater than 81. Okay, it has to be greater than 81. So you could try 82. Does 82 work?
Oh, yeah.
Yeah. Now what about this one? We have X is going to be less than 2 to the 4th power. Because remember, base, 2 is our base. And 4 is our exponent. Okay. So then X is less than 16. But we also have to do the other part, because it's a less than sign, because there's a lot of numbers less than 16, even lots of negative numbers, which we can't have, right? So we also have to say X is greater than 0. And we can write it like this up here. So this is how we will write it. All right, so this next rule is very similar to in the video when they have the same log and the same base. We can just set our A's, quote unquote, in an inequality. So you can go ahead and write this up here. Feel free to just write down the highlighted portions if you'd like.
Oh.
And then write this example down. Okay, so we set this up putting our A's, just looking at those in the inequality. So X plus 3 is greater than 2X plus 1.
Okay.
Solve for X. We're going to subtract X from both sides, subtract 1. We end up with 2 is greater than X, so X is less than 2. Now we're not done yet. What else do we have to do? Equal to 0.
Oh, my.
No.
Less than.
Plug it back in.
These have to be greater than 0. So here's the other portions of your inequalities that you need to solve for. So go ahead. So when you do this, you have to decide which one of these you're going to use. Are you going to use X is greater than a negative 3 or X is greater than a negative 1/2? So let's choose something in between negative 3 and a negative 1/2. Let's choose negative 2. Something in between a negative 3 and a negative 1/2, so we're going to choose negative 2. So does negative 2 work to make these positive? Will these be positive if I choose negative 2? This one will work.
Oh,
This
yeah.
one will be positive, but will this one be positive?
No.
No, so we're not using this one. So let's choose something greater than a negative 1/2 but less than 2. Let's choose 0. Does 0 end up working?
Oh, yeah.
Yeah. So our final answer will be a negative 1/2 is less than X, which is less than 2. So you do have to do these two parts to figure out, or to make sure that your A is positive. This portion has to be positive. So those always has to be greater than 0. Another example. All right, we're going to do another example. Go ahead and try this one. 7th period, you can pause the video here. I apologize for skipping around, trying to get certain students out of the video.
Just say
Okay.
my name.
So you should get x is less than or equal to 3. But we're not done here.
No, we're not. You gotta plug it back into zero. You plug it back in.
But wait, there's more. You gotta have these be greater than 0, your a's, because we want them to be positive. So go ahead and do that and see which one you're going to use.
Put 3 in there.
So you should decide if you're going to use greater than a -1/2 or greater than a -4. So let's choose something greater than a -4, but less than a -1, just to see if -4 works. So for example, you could try -3 or -2,
It's not gonna work.
whatever one works. Will it work? No, it doesn't.
not
It doesn't work, does it? So what's something greater than a -1/2? So this one doesn't work. We could try 0. So does 0 work? Will we get positives?
Well, no.
Yes. So your answer, your final answer, should be written like this: x has to be greater than a -1/2, but less than or equal to 3.
So you could plug in like 14 and it would work.
Mrs. Davis?
Disregard that last comment.